Hi all, myself Biren Pratap Singh. Today I am going to teach you basically why need gate driver circuit to turn on the MOSFET. Earlier I have discussed about the how to turn on the MOSFET, how to turn off the MOSFET, how to calculate the switching losses from datasheet. I have discussed earlier. We can see in playlist also, but I will proceed in this lecture. Basically, why we need the gate driver circuit to turn on the MOSFET, we can see here. Basically, in left side is microcontroller and right hand side is MOSFET circuit are there. Why we need, I will explain with example, through example. Suppose that to turn on the MOSFET, we need to apply VGS voltage across above the threshold voltage. Here I am taking threshold voltage is 2.8 volt. So suppose that we need to get to turn on the MOSFET 5 volt we are applying for a particular application. Switch frequency is 2 MHz and gate charge is given from datasheet. We can calculate the switching time, reciprocal of the switching frequency. Here I have got it here 500 nanosecond. By using, we have calculated the gate current. Gate current is equal to QG into switching time. I have calculated here gate current here 2 ampere. We can see here voltage is sufficient. 5 voltage is given by the microcontroller. It is okay, but we need also to turn on the MOSFET 2 ampere current, but in microcontroller is milliampere current. That is not sufficient current to turn on the MOSFET. That's why we need the gate driver circuit, because basically gate driver circuit is nothing to do. Basically it is fed the current, whatever requirement of the current to the turn on the MOSFET with given a time. Because of very important factor is switching frequency. Switching frequency means switch time is very less. We need to switch time very less. In this particular time, we need to fed the current to turn on the MOSFET. That's why we need gate driver circuit. In this slide, we can see here the gate driver circuit is fed between microcontroller and gate driver circuit. Here VGS, we need to apply about the threshold voltage. Basically here threshold voltage I have taken 2.8 voltage. Basically whatever requirement of current, whatever requirement of gate to source voltage, that voltage and current will provide by the gate driver circuit. Because of microcontroller will not provide 15 volt, and in some cases, and that much current will not provide. Basically gate driver circuit is nothing. Basically it is a amplifier. It is any amplifier. Basically input capacitor and gate resistor will create a RC circuit. Basically gate resistor will play a very important role. Basically it control the switching frequency, how to fast, how to slow charge the capacitor will depend upon response of the circuit. Basically this is RC circuit. Basically I have taken, we know very well VCT is equal to VDC 1 by T by tau. Basically suppose that I have taken here, so that time constant is RC. Suppose that input capacitor is constant, I have taken here. Suppose that if we increase the gate resistor, then time constant will be more, then our response will be slowly. In slowly, suppose that in these cases losses will be more, but one advantage are there is peaking. Switch node peaking will be